Hello, my Calc 2 student. We start week number 3. Then we try study integration. Today we cover section 8.1, and we remember basic integration rule. Some rules when you use before and it's only remember. First one, expand. Usually it's happened with numerator. Okay. First one. I put in the number 1, 2, 3, 4, 5, 6, 7. Will be 7 rules, but does not mean something first because it's better than something 6. It's only will be sure and write all of this. This means first one, expand. And I have some example. For example, I have integral from 1 plus e exponent x squared dx. Easy way, distribute, and see what we have. 1 plus twice e exponent x. E exponent x squared, this means e exponent 2x dx. Now you have 3 simple integral. X plus twice e exponent x plus 1/2 e exponent 2x, because coefficient 2 we have, plus c. Separate numerator. Second sum integration rule. Separate see some example. 1 plus x over, let's go our function, x squared plus 1. Integral dx. This means, let's go. One fraction, this will be 1 over x squared plus 1 dx. Second one will be x over. I'm not only separate, I'm separate 2 integrals here. X squared plus 1 dx. First one give us its table integral, arc10 x. For second one, maybe you need more work. I write different color one, you can see. X squared plus 1, let's go, it's new variable t. Then 2x dx, it will be dt. And your integral will be 1/2 dt over t, will give us 1/2 ln t. If you go back and remember what is t is, you have plus 1/2 ln x squared plus 1 and plus c. Here I not use absolute value because x squared plus 1 is always positive. Okay. We can sum. What happened? Oh, no. I'm try only. Okay. I'll try only clear here, nothing more. Okay, one more rules. Complete the square. You remember we used this rule. When you have something integral like work inverse trigonometrical function, for example, you have dx over square root 2x minus x squared. How you remember? It will be dx over square root 1 minus x minus 1 square. will be arc sine x minus 1 plus c. Okay, next one, divide improper rational function. What happened if you have rational function inside integral and power your numerator highest or equal power your denominator, then you need numerator divide by denominator. For example, number 4, I write name this method. It will be divide rational function. Let's go. We have integral x squared over x squared plus 1. You can see here we have, if you remember how divide, you have x squared, we need divide by x squared plus 1. It will be 1. X squared plus 1, subtract, it will be negative 1. Negative 1 is our remainder. This means here we have integral 1 minus 1 over x squared plus 1 dx. And now it's no problem anymore. We have integral from 1. It will be x. Integral for this fraction, it will be arc 10 x plus c. Okay. Next one, add and subtract terms in numerator. Okay. The terms as you can be terms with variable or only constant, is all depend what you have here. Okay, number 5, add and subtract terms For example, I have integral is 2x over x squared plus 2x plus 1 dx. What I need to subtract? If I'm looking for whole my denominator, I see derivative this denominator. This will be 2x plus 2. Right? What I do? I have 2x x squared plus 2x plus 1 is nothing changed. Dx is not changed. But here I'm add 2 and subtract 2. And now I can rewrite. Here is like 2 integrals. One is 2x plus 2 over x squared plus 2x plus 1 dx. And second one, minus 2 integral dx over, but if you're looking for denominator, it will be x plus 1 square equal. Because we add and subtract 2, especially when it's numerical first fraction, it will be exactly derivative your denominator. Here we have first integral, it will be natural log from x squared plus 2x plus 1. A second one is minus 2. Power x plus 1 is will be negative 2. Add 1 is will be negative 1. Okay, x plus 1 power -1 divided by -1 plus c. Now I write a little bit better. Square plus 2 over x plus 1 and plus c. This is final answer. One more question. When you have trigonometrical integral and you need to use some trigonometrical identity. For example, you write use identity Sometimes we use more than once that something happened, but now I take it something very similar. Integral from tangent square x dx. Looks like scary, but we remember tangent square is secant square x minus 1. And now our integral is not scary anymore. Integral from secant square is tangent. Integral from 1 is x. And plus c. You see, we solving our problem. And last but not least, multiplied and divide by Pythagorean conjugate. For example, alright, multiply and divide, and here we have some dx 1 plus sine x. This is a situation whereas integral looks simple but very difficult for solving if you don't have if you don't know some trick. Now we multiplied and divide by Pythagorean conjugate. What is will be from 1 plus sine x? This will be 1 minus sine x. Okay, this is 1 plus sine x. I'm use different color. 1 minus sine x multiply 1 minus sine x divide. You see, it's because I multiplied and divide for something same is nothing changing, but this means I can do it. 1 minus sine x. Denominator is now is 1 plus sine x, 1 minus sine x. This will be differ to square 1 minus sine square x dx. Great. Now we need use some trigonometrical identity because 1 minus sine square x this will be cosine square x. This means we use rule number 6 for moving from one integral to another. Now we need use a rule number 2, separate numerator. And what we have? 1 over cosine square x minus sine x over cosine square x dx. Maybe we'll write one more time. 1 over cosine square x this will be secant square x. Sine over cosine square, you can rewrite like minus tangent x secant x2. You see, we use trigonometrical identity one more time, but now it's no problem. What is secant square? Integral from secant square is tangent. What is integral from tangent secant? Is secant plus c. You see, last example show us we not use only one rule. Usually we use all of this rule. Maybe not all, but we use more than one rule. Okay, doing some example from your book who help you doing homework. I have Dream, my student, doing homework, okay? What we have here? 2c plus 1 over t squared plus c minus 4 dt. If you're looking for this integral and prepare and try doing something, first, look for your denominator and try doing found derivative this denominator. T squared plus t minus 4, derivative will be 2t plus 1. Exactly your numerator. This means here, easy way for solving, only substitute t squared plus t minus 4. What variable you want, for example, x. Then take a derivative, you have 2c plus 1 dt will be dx. And here we have integral dx over x. We all remember this is natural log absolute value x plus c give you natural log absolute value t squared plus t minus 4 plus c. Okay. Doing one more example. It's word substitution too. For example, number 18. Here you have integral from t cubed square root from t4 plus 1 dt. Great substitution because t4 derivative, t4 plus 1, t4 plus any constant, it will be something with t cubed. This means you almost have t4 plus 1. Let's go, it will be u. 4 t cubed dt. It will be du. This means we need 4 here. I'm right 4 there. But if I multiply by 4, I need divide by 4, right? 1/4 there. And my integral will be 1/4 integral square root from u du. Oops, I don't need parentheses here, sorry. And I have 1/4 for u power 3/2 over 3/2 give me practically plus c. It will be u is t to the 4th degree plus 1 3/2 2 out divided by 6 plus c. One more question. I try to show you more possible interesting example will be you will be free for solving. For example, number 24. Oops. Tell me please what I tell 24 and write something 3. 24 integral 3x over x plus 4 dx. Here you have rational function. We have numerator maximum degree is 1. Denominator maximum degree is 1. This means maximum degree is same. This means we need first divide. Okay. 3x divided by x plus 4. You have 3x plus 12. Subtract negative 12 is your remainder. Great. This means this integral will be 3 minus 12 over x plus 4 dx. And now we're done, because integral from 3, it's 3x. Integral from this fraction, because denominator is linear combination x, it will be natural log. This means minus 12 natural log absolute value x plus 4 plus c. That's it. Okay, I found something, or maybe 3 more example. This I found something more interesting and more a little bit difficult. For this is question 46. 1 over x squared minus 4x plus 9 dx. Numerator here is only constant 1. This means we cannot do anything except we found whole square here. Okay. Integral 1. I have x squared minus 4x. This means full square. I have x minus half of 4. It will be 2 squared. This is give me x squared minus 4x plus 4, but I don't have plus 4. This means I'm subtract this 4 and add 9 what I have before. Okay. One more step. Integral dx over x minus 2 negative 4 plus square. Negative 4 plus 9, it will be plus 5. Great. But now it's stable integral. We have arctangent, whereas function u is x minus 2 and a square is 5. This means a is square root of 5. Okay, right. Arctan, our function x minus 2, divide by coefficient square root of 5. Don't forget in the front you have 1 over square root of 5 and plus c. Okay, one more. This is question number 60. Here we have integral from 1 to e 1 minus natural log x over x dx. Here is your choice. You can separate for two fractions, or you can do it right now, substitution. Okay, maybe we're doing right now substitution. First I'm thinking about separate, but no, separate is better. Okay, integral 1 to e 1 over x minus natural log x over x dx. Integral from first term is no problem. We have exactly natural log x. What about ln? This is from 1 to e. What about ln x over x? Here we have, okay, ln x, let's go, it's u, then dx over x, it will be du, and my second integral, maybe I go backwards, it will be u du, but because I'm change my variable, and because I don't want to go back with old variable, because I have border here, I'm counting. What happened if x is equal 1? U is equal 0, because natural log with 1 is 0. What happened if x is equal e? Natural log with e is 1. And then we have ln x. Okay, I write one more time. Add u square over 2 from 0 to 1 equal, we can evaluate. It will be ln e is 1. minus ln1 is 0, minus, if you have 1, this means minus 1/2, and if you plug 0, it will be 0. This means 1 minus 1/2, you have exactly 1/2. This is your answer. And last one for today, we have number 62. You have integral from 1 to 3, 2x squared plus 3x minus 2 divided by x dx. I think here is better way. Separate for 3 fraction. 1, 2, 3. We have 2x squared over x plus 3x over x and minus 2 over x all of us dx. Simplify each terms. We have integral from 1 to 3. Here will be 2x plus 3, and only last term is still 2 over x dx. Give me 2x integral, it will be x squared. 3 is integral, it will be 3x. And here we have minus 2 natural log x. And for all of them, we need plugging border from 1 to 3. Okay. Plugging 3, what we have here is 9 plus 9 minus 2 ln 3, plug 1, you have minus 1 minus 3, and ln 1 this will be 0. Okay, this will be 18 minus 4, this will be 14 minus 3 ln 3. This is final answer. Okay, tell me please how it's 2 moved to 3. This is 2